All right, it's rolling again. Thank you. All right, so to give you some numbers here for ice, specific heat of ice, it's 2.05 joules per gram degrees Celsius. And for aluminum, I'll write it down here somewhere. For aluminum, I have 0.215 calories per gram degrees Celsius. Now, obviously, there's a big difference between these two in the fact that they're both grams per gram degree Celsius, but I've got calories here and joules there. What's up with that? What's a calorie? Pardon? Ah, you're talking about the food calorie. That is not the same as this calorie. Because, of course, you've got to have different meanings for the exact same word. All right. Calorie is a unit of energy. So in that respect, yes, absolutely right. This is not the food calorie. When you eat a 1,000-calorie meal, what normal, you eat a couple thousand a day?
2,000.
2,000? All right. So when you eat 2,000 calories a day, this is not the same as this calorie. So let's first talk about that relationship there. One food calorie is generally labeled as a calorie with a capital C, and that's equal to 1,000 calories with a lowercase c. So one capital C calorie is equal to 1,000 lowercase c calories, which is the same as a kilocalorie, 1 kilocalorie. So when you eat 2,000 calories a day, 2,000 food calories a day, from a physics point of view, you're actually consuming 2 million calories with lowercase c. Assume that anytime I'm talking about the uppercase C calorie, I will actually use the word food in there. Any other reference to calories, I'm referring to the physics calorie, but not the food calorie. Now, I've tried to figure out why they bothered. It's just a factor of 1,000. I mean, if we had all grown up with you need to eat 2 million calories a day, I don't think it would seem unusual. All right, now we have this calorie joule issue here. They're both units of energy, so therefore there is a conversion factor between the two. And so we have, there we go, 1 calorie is equal to 4.184 joules. So if I want to figure out how many joules this is, well, I multiply times 4.184 joules per calorie. And so what's 0.215 times 4.184? Was that 5.6 or 5? Oh, correction, 6.
It was 5.6, but you could
All
have
right.
6.
And so that would end up being joules per gram degrees Celsius. All right, so looking at these two numbers here, the specific heat of aluminum is under 1, the specific heat of ice is above 2. This means it takes more energy to change 1 gram of ice 1 degree Celsius. So if I have a gram of aluminum and a gram of ice, this will take more energy to change the temperature. The smaller the number, the easier it is. The other thing I wanted to talk about is this bit right here, degrees Celsius. There are 4 major temperature systems, scales. Okay, 3 major ones and one that's gotten lost in the dustbins of history, but we're going to talk about it anyway. We have degrees Celsius, degrees Fahrenheit, Kelvin. Anyone happen to know the other one? The absolute scale related to Fahrenheit? It's just not taught anymore. Good thing you're taking this class, the Rankine. This is Kelvin. I think it's actually degrees Rankine. I've been, probably on the video, other videos I talk about it being Rankine and not degrees Rankine. I think it might be degrees Rankine. It's definitely not degrees Kelvin. It's just Kelvin. This is degrees Fahrenheit. Let's just get the tag in there. And then degrees Celsius. As mentioned in the video, I might call Celsius centigrade because that's the way I was raised. Centigrade makes sense because it's from freezing to boiling point of water. It's broken into 100 different grades. But they're based on, so these two are based on the freezing point and boiling point of water. Sorry, we'll try that one again. So 0 degrees Celsius is the freezing point of water. 100 degrees Celsius is the boiling point of water. Zero degrees Fahrenheit was the coldest thing that Fahrenheit could create. Coldest substance Dr. F could create. And then 96 degrees Fahrenheit to him was body temperature. Why 96? Because a whole lot of numbers go to 96. It's divisible by a bunch of stuff, similar to 60 when we talk about radians. 96 just has a lot of factors into it. It makes the math easier, so that's why you pick 96. But on this scale here, 32 degrees Fahrenheit is the water freezes, and 212 degrees Fahrenheit, water boils, assuming standard pressure. And body temperature, what is the average body temperature for humans? Pardon?
Is it like 98.6?
That's what it was about 150 years ago. It is not that anymore, but that's where 98.6 comes from, is because, I don't think it was Fahrenheit, it was somebody doing body temperatures and came out with 98.6 was the average. And that is sort of stuck in the mythology.
You just told us it was 96.
Now, that's what Fahrenheit came up with, but it has actually changed.
97?
Not that quite as low as 97, 97.9, somewhere around there. So when I went to the school nurse in elementary school saying I had a fever, she took my temperature and it said 98.5, I did have a fever. As opposed to it's under 98.6, you're fine. Now, 98.5, not really worried about that at this point in my life, but, at that point, I didn't feel good.
What does the 0 degrees Fahrenheit say? Coldest?
It's the coldest substance,
Okay.
coldest substance that we'll give him a doctorate, Dr. Fahrenheit could create. It was some combination of salt and water.
Oh.
These are absolute scales, 0 Kelvin It is not okay, it's 0 K. 0 Kelvin and 0 Rankine are both considered to be absolute zero. Since temperature is related to how fast the molecules are moving, if you took a substance and got it so that the particles stopped moving completely, no vibrations whatsoever, that's absolute zero. Kelvin and degrees Celsius are related, Rankine and degrees Fahrenheit are related. So if I take Kelvin is just the degrees Celsius plus 273.15. Rankine is just, you take the degrees Fahrenheit and you add 459.67.
That's if we wanted to know the degrees in Kelvin or Rankine.
Pardon?
That's if we wanted to know the degrees in Kelvin or Rankine.
Yes. Now, Rankine I only put up here just for the trivia of it, just so that I don't want his name to die in terms of temperature. It is, it's officially the scale that we use. According to one source, it actually, you do find it every once in a while. I have not run across it since school. Actually, I should say since I probably saw it in middle school or elementary school. Kelvin is the standard unit in, it's the standard international unit. And on that note, I'm partway grading all of the centrifugal motion ones that were done on paper. I have graded and I have a grade on them. I am occasionally making references back to them as I'm grading the electronically submitted ones. So if you desperately want it, I'll give it back to you now. Otherwise, I'll give it to you on Wednesday. And I guess Wednesday is the last day before the last test. Oh, we were gonna do the multiple choice thing starting today. I guess we'll do that on Wednesday. That multiple choice test, you took the first day. I even pulled it aside so I remember to bring it. Written on my calendar. Well, if I keep forgetting, you'll be doing it on the last day also, you'll have 2 tests that day.
We'll make sure you don't forget Wednesday. So we got a test on Monday?
Next Monday, yes, the last day of class. Next Monday, yep.
Okay, wait.